thumb on just implementing SQL Server as a product in an infrastructure as a service kind of environment, and then specifically always on in infrastructure as a service. And then I have a slide at the end that has some incredibly helpful links to different resources from Microsoft on the topic. A little bit about me. I work at Oakwood Systems. I am a senior SQL consultant as well as the SQL lead for the managed services team. I've been there for about a year and a quarter at this point. I have an MCSA for SQL 2012, and I also have my MCP for implementing Azure infrastructure solutions. I try to blog when time allows. Time has not been generous for me lately, but I put my blog address up there as well as my email addresses. So if anybody has any questions about any of this, feel free to email me. I am generally pretty responsive. All right, so Azure 101. There are two main kind of ways you'll deploy SQL into Azure. There's the Azure SQL Database, which is a PaaS solution that's platform as a service. There are some pros and cons to this. You don't have to manage the OS or the hardware. You can spin up a database or an instance extremely quickly, just a couple PowerShell commands, and you've got yourself a shiny new instance. I didn't list this, but actually they have been rolling out features incredibly rapidly into the PaaS builds. So the row-level security that's coming out in SQL 2016 has actually been GA there for, I want to say, almost a year at this point. So they roll new features into the PaaS offering, which is kind of nice because you don't have to wait until that next big release to get a hold of them. The high availability and fault tolerance is also built into the platform. You just say, hey, I want this to be highly available, and they make it so. You just pick which regions you want it in, and they will spin up a secondary that is either readable or not, and off you go. Cons, you don't get to manage the OS or the hardware. It's a pro and a con. It's nice to not have to do it, but at the same time, it can be maddeningly frustrating to not be able to do it. You get very limited insights into what the instance kind of load is through the DMVs. It's a much more restrictive kind of DMV list that you have available to you as a part of kind of normal troubleshooting procedures. You get, and that kind of segues in, you get very little control, aka none, over the instance itself. And last but not least, there are requirements that your database has to meet in order for you to be able to move it there. I am not current on what those are at this point. They are kind of changing. They're getting less restrictive, but right now there is a TechNet post that just has kind of a bulleted list of everything your database can't have if you want to move it to Azure SQL Database. The next offering is IaaS, which is Infrastructure as a Service. This gives you complete management of the guest OS. It also gives you complete management of the instance. There's no upfront expenditure on hardware, and it's also a pretty quick deployment. Cons are also you have complete management of the guest OS. It's kind of a double-edged sword. You have to make sure that you are kind of keeping up with the OS maintenance as well as the SQL Server maintenance. You don't have any visibility into the infrastructure for issues that may be related to the infrastructure. So essentially, if there is something wrong at the OS level, or at the VM level, you are essentially just opening a ticket and waiting to see what happens. The recurring monthly cost can be a con. You don't get that kind of initial spend, but at the same time, you're going to keep perpetually paying that monthly fee. And another con is should have probably footnoted this one. There are no SLAs around performance. That changes a little bit with the addition of premium storage. You actually do get some performance metrics around that now. So it used to be you had SLAs around uptime and availability, but not around performance. So they're moving a little bit more away from that and getting more into kind of focusing on giving you that option. This is kind of listed right off of Microsoft's site. It's just kind of a good breakdown of the different offerings that are out there, as well as strengths and weaknesses, just kind of as a chart. All right, so here we're kind of segueing into architecting in Azure. So like I said, a big piece of this is storage because it's one of the most configurable options you have available to you. It's also one of the bottlenecks that you will most commonly encounter in any SQL Server install. Another thing to be aware of is the processors kind of fluctuate a little bit with these different sizes. So I kind of noted up there that the A8 and the A11, or through the A11, are known as compute-intensive instances. You get an upgraded processor family with that. It moves into the E5s versus the kind of the commodity AMD Opterons. You can get Intels if you don't use the compute-intensive sizes, but it's random, and if you really want to make sure that you have a better processor, you're going to want to look at those different sizes. Another thing that you'll notice kind of is the local disk that is kind of in the middle of that. They give you a local disk that is locally attached. There are no availability SLAs around that guy, so you have to be very careful about what you put on there, because if the machine does get deallocated for whatever reason, where it's kind of a hard reset, it will wipe everything that's on there. So you don't want to put tempdb in there. I'll subtitle that as well because there are cases where you do, but you have to be careful about how you do it. There are things you have to do to make sure that you don't get bit and your instances come back up online if they do restart. But it's a nice place if you're, running integration services packages to just dump some flat files. If you can just regenerate them on the fly, it's a great place to put them, just so that you're not impacting any of your SQL workloads. The memory kind of moves up as it's kind of at an odd interval, but you usually get more memory the higher you go. You'll see in there's kind of like a reset where it drops back down, or it stops increasing, and that's mainly due to the differences on the disk side. So the disks, the important thing to know is how many you get and what the IOPS are per disk. So you generally get 500 IOPS per disk, and then that scales pretty well based on how many disks you have available to you. So the A series, I think, caps out at 32. The D series also caps out at 32. And there's a G series. I didn't put that on here. That's for the really high-performance workloads. They're kind of InfiniBand connected. There are a lot of really cool features in that family. They're just kind of cost-prohibitive. I haven't gotten to play with them, so I didn't want to put them up here. But whenever you are in the A series, another important thing to note is your temporary disk or your local disk is spinning. Whenever you move into the D series, you start getting an SSD. So that's where you start getting into, it makes sense to put your, tempdb, for instance, on your SSD just for the performance of it. But like I said, there are kind of considerations that I'll touch on later that you have to take into account when you do that. And then after that, and this is a recent kind of change in the landscape, Microsoft GA'd their premium storage, where I was kind of mentioning, you'll see that this table is a lot bigger than the other ones because they're starting to give now performance metrics around what you're going to get whenever you start provisioning premium storage. It costs more, but at the same time, if you need the performance, then it is what it is. So again, you get local solid state storage for your temp drive. The processors are all kind of the E5 family, so you get those kind of compute-intensive processors. And then the other important thing is that your the IOPS and throughput that are on the temp disk do not count against those max VM IOPS and throughput restrictions that are on there. One thing you also want to be careful of if you are playing around in premium storage is you do have max VM IOPS, and those may be lower than how many disks you add. So you don't want to add, you know, a bunch of P30 disks to a, we'll call it like a DS3, because it's still going to cap you. So you're basically going to be paying for all those disks, and your performance is still going to be capped. Your throughput is still going to be capped at the VM level. But the fact that the temp disk does not count against the VM IO throughput and operations kind of makes it even more attractive at that point to place tempdb, for instance, on that drive. All right, so some of these are hard-learned lessons, what not to do. For the first one, I'm going to say that, for the record, that was not me. I was the one that kind of walked into that. But software RAID, you do not ever want to use. It actually can cause you performance issues that make your disk less performant than using one singular disk. So don't ever do that. I'll get to how you should scale your disk in the next slide. But yeah, don't ever use the software RAID. It can make your disk performance really bad and also really erratic. Don't ever not use all of your data disks. Always use the max for the VM. The reason for this is you're only paying for the blocks that you write to the disks. So you could basically have 16 terabytes provisioned to your VM. You're not paying for 16 terabytes of storage. You're paying for the 300 megs that you kind of grew out onto. So as you're writing it, that's how they meter what you're being billed for. So you always want to kind of max out both I personally feel that you should max out the capacity as well as max out the number. And the reason I feel that way is it's always easier to kind of just grow on into the space than it is to then have to reattach new disks and start shuffling that way. Here's where I kind of get into that recommendation of don't put anything important on the temp drive. To local storage, no redundancy, no guarantees around availability. If it kind of hard faults, you lose everything on there. The caveats around it are on D series and up. Definitely put your tempdb in there, but along with it, you have to put some mechanism, whatever your preference is, to automatically, if you have tempdb in a subfolder and not just sitting in the root drive, you need to have something that creates your folder and stripes down the permissions. Otherwise, your SQL instance will not start up. You could make it a local admin, but don't do that. All right, so here is what you should do with your Azure storage. Use storage pools. The only way to get data disks to scale their I/O. They actually scale pretty linearly up to 4 disks. And even whenever you start experiencing that breakdown, the writes actually scale better than the reads, which was kind of weird for me, but it was what it was. And then also the stripe data files. So if you were to just attach 16 disks and then basically make file groups, stripe your data files over, put one data file on each disk, that actually is the best performance option. So you will receive the best scaling out of that option. However, it is also the most difficult to manage, as well as loss of a single disk will offline your databases. Kind of true with the storage pools too, just based on the fact that you only provision your disks as you only provision the storage pools as simply redundant. So they're basically striping over all the disks. And the reason for that is the Azure disks, just by architecture, are locally redundant. So every time you write to disk, it writes to 3 separate disks. So you have that fault tolerance at the kind of the Azure architecture level. So the idea is that you don't really need to architect it any further. 3 disks is more than what most people run with anyway. Is another kind of offshoot of that. There is an option with storage accounts that you can make storage accounts geo-redundant, and what that means is the disks are locally redundant, so you get the 3 copies, but then they're also geo-replicated over to another region or data center. And there's no guarantee over the order that it arrives, so it's completely pointless to do for SQL Server. It's nice for, file shares and things like that, but for SQL Server, if you can't guarantee the data is arriving in order, you can't recover from it anyway. So it's one of those things where it's a nice feature, but it's not nice for SQL. There's no reason to pay for it. You can spend the money on a better instance. And then also you can't stripe the transaction log files in any meaningful way for performance. So that's just yet another reason to use kind of storage pools. If you want to be able to get more than just one data disk's performance out of your transaction log, then you need to put a storage pool together and throw your transaction logs on there. All right, so I'm always fascinated by holy wars in database administration. I feel like this is probably another one. There are 2 methods for deploying storage pools. You can throw all the disks in one storage pool and just kind of carve volumes out of it, or you can make multiple storage pools and still carve kind of volumes out of it. And I'm kind of stoking the fire by saying there's a right way and a wrong way. So the reason I like to break up the disks by purpose in the storage pool is it has absolutely nothing to do with kind of the adage of, you want to split it up because for separate, I/O patterns, you are going to optimize differently. You can't really optimize them anyway, so it has no bearing on the conversation. However, the point that I like to point out is, you want to at least have that guaranteed throughput that is going to your transaction logs, going to your tempdb, that's going to your data files. And I don't like the notion that, my tempdb could be kind of bullying my transaction logs out of performance. So I kind of err on the side of caution, and I like to provision those separately. You may be passing out on kind of being able to peek out certain areas at different times, but again, at the same time, I like segregating out the workload to guarantee performance for them. You can also put all the disks in a single storage pool and let SQL Server figure out how it's going to use the I/O. It's completely valid, even though I say it's wrong. So another thing that this one I did learn the hard way. Definitely create storage pools before you create your failover cluster. The reason for this, and I have multiple hours learning my lesson on this one. The reason for this is if you create them afterwards, they get added as cluster resources by default. So you're going to have to basically go through and remove them because you can't have shared storage for this. So you basically go through and you remove them from the cluster, and then everything is happy again. You can just create them before, and then whenever you are going through the the creation of the cluster, you just don't add available storage to it, and everything's fine. All right, so implementing SQL Server in Azure IaaS, instance configuration still matters. It's just like deploying on a VM that is kind of on your own local hypervisor. You still have to go through all the kind of the standard modifications. So, instant file initialization, you want to enable that. Lock pages in memory, again, another holy war concept. I like to enable it, but I get a little more aggressive with my max memory settings so that I don't starve out my my OS whenever I am enabling this. And then power plan settings. Set it to high performance, balanced by default. This is the weirdest thing that I have ever encountered, but I did find that it's not as pronounced as a bare metal install, but there was still a 6 to 8% performance improvement at the processor level. I don't know why. All I know is I ran that test probably about 20 times because I couldn't believe it myself. So you still want to change it. It's just easy, low-hanging fruit. Also, the standard kind of instance configurations still matter. So your max and min memory settings, any fill factor defaults. So this is kind of on an app basis. If it's a back-ending like a vendor app and they have recommendations around setting it globally, like SharePoint, then you still want to set it here. Always, I always like to set up backup compression as being on by default. Optimize for ad hoc queries. You want to make sure that's enabled. Cost threshold for parallelism and max stop. You want to tune those accordingly. And then also TempDB configuration. So you still want to do, even if you're on the SSD, the local SSD, you still want to do the multiple equal-sized data files, as well as the two kind of trace flags, so 1118 and 1117, which are kind of those. Is everybody familiar with those, just out of curiosity? Or should I actually say what they are? Okay. And I might get these backwards in terms of which one's which, but I'm pretty sure 1118 is the trace flag that enables files to grow, so at the same rate. So an auto growth event on one file will cause all of the files to grow, and that really helps to maintain the size being equal for all the data files. It's an instance level setting. However, the biggest kind of reason you do it is for the TempDB, and that's kind of a really internal-y kind of TempDB conversation. Bob Ward did a fantastic presentation on this at PASS like 3 years ago. It was like a 3-hour session. I didn't know that there was that much stuff about TempDB, but he touched on this one, and then 1117, which forces uniform extents versus mixed extents. So basically any new page allocations will come from a uniform extent instead of a mixed extent. It's kind of a way to help decrease the contention inside of TempDB on those kind of the shared global allocation map, the global allocation map, and then also the page free space kind of maps. So those two are really important, I feel, to enable. And they are pretty universally recognized as safe trace flags. So, all right, so then we come to implementing Always On in Azure. So deploying Always On in general is pretty much the same as doing it on-prem. The only difference is when you're configuring the listener. That's the part where it gets different. And it all revolves around kind of having to shuffle around the IP and what IP you're shuffling around. There are two ways to configure your listeners. There is now, this is recent as of a year and a half ago. Before that, it did not exist, and that's the internal load balanced endpoint. And that uses an internal load balancer. And then there's the external load balanced endpoints. So those are the two kind of methods for doing it. I'll touch on differences a little later. The main important part is that external load balance endpoints requires that you are opening traffic into your SQL Server via the public IP address that is assigned to your cloud service, whereas the internal load balance endpoints is only for traffic that's routing internal of your virtual network. So personally, the first one is more secure just by how it works. Okay, so I put together kind of just a straight rundown of how you kind of deploy in Azure. So I'm going to kind of go through this, and then there are some PowerShell scripts that also they're readily available on Microsoft's site. They actually have a fantastic tutorial in doing this. However, there are some things that you have to do beforehand. I found that while it's nice to get those PowerShell scripts off of there, there are some other more clear ways to kind of speak about what you need to do. So first thing you have to do is you have to create your cloud service, storage accounts, and your VNet. So the cloud service is really just kind of a container for VMs. Each cloud service gets its own public IP address, and you can declare endpoints on your cloud service. Storage accounts are basically what's holding your data disks. So those actually have some restrictions around them. Storage accounts are capped at 20,000 I/O for the storage account as a whole. So whenever you start getting into kind of the beefier sizes, you're going to want to create multiple storage accounts for some of these VMs. Otherwise, you're going to cap at the storage account level and not at the VM level. So if you're building out like a D14, it's got 32 disks, you're talking about max I/O through operations of about 16,000. So if you're deploying 2 of those in an availability group, then you're needing 32,000 I/O, which you're going to basically cap out at 20, so you're losing 12,000 of your I/O that you should be getting. And in deployments that I do, I will provision separate storage accounts for all of my SQL servers, just because it's also nice to get those kind of reporting metrics separately as well. And then the VNet is also, it's essentially just specifying the subnets that are going to be available. And you basically, whenever you're creating your VMs, you are creating those into those subnets. That's something that actually has to be done at the creation time. You can't move them. You have to basically delete them and remake them. So it's definitely worth kind of investigating a little more thoroughly on the VNets. Another thing that it's kind of legacy at this point, but with VNets you used to be able to do, or I think you still can, but the big way to make sure that your machines were all staying kind of locally close in the Azure data centers was to create what's called an affinity group, and then you basically put all the resources that you want locally, like geographically near each other in the data center. You put those in an affinity group. You can't actually use an internal load balancer with an affinity group, so it's a nice feature, but it's probably one that's going the way of the dodo bird. So then the next step that you have to do is, and again, this depends if you even need a domain, but you create a new domain for Azure if this is an all Azure space, or if it's going to be hybrid, you extend your domain into Azure. That's a little bit outside of where I usually focus. I'm usually more focused on the storage portions as well as the actual VM performance in Azure. So I'm not going to have a ton of details on that, but I mean, creating a domain in Azure is pretty straightforward. It's just like you would do on-prem. You just throw a DC in there and make your domain. Then you are going to basically create your Azure VMs, and you got to make sure you create those in the right cloud services as well as in the right VNet subnets. And again, alluding to the fact that you can't just move them around, you have to delete them and recreate them in order to move them. And then after you've created them, join them to the domain. And then the next thing you are going to do is you're going to add your Azure data disks to the VMs. And this will be dependent on the size of the VM instance that you spun up. But I actually, you know what, I will pause this right now and bring up, where'd you go? There you are. All right, so one of the nice things about deploying in Azure is it's really straightforward to interact with it. So PowerShell, I'm not going to purport to be a PowerShell guru, but I mean, it's pretty straightforward. This PowerShell script is essentially just going through the different VMs, and it is basically you're specifying how many disks, what size you want the disks to be, and it just basically goes through in a while loop and it adds the disks. Just to give you an idea of how long-ish that takes, I did have one customer where we were provisioning out about 32 500 gig drives for their server, and it took about 15 minutes to add all those in there, so it's pretty quick. And there are PowerShell commandlets for essentially anything you could ever hope to do. So right here is kind of where the magic happens, so to speak. It's just you'd say I'm adding an Azure data disk. It's a new one. Here's my disk size. Here's my disk label. Here's where I want you to put it, and that essentially points to your storage account. So that's really all you have to do. And then you're just telling it what LUN it is, and last but not least, you update your VM and move on to the next disk. So it's, again, like I said, it's really straightforward to kind of interact with Azure via PowerShell. And I guess while we're here, I could also kind of show this one off, which is in order to create the VMs, I basically, for this, I created, so that I could get like screen captures for the presentation, I created 3 VMs to kind of play around with for this. And this is essentially all that I had to do, and that creates them in the right cloud service, right static IP address, the right VNet, and with the proper version of the OS that I wanted. And that was all there was to it. I started it and went and put my kids to bed, and when I came back, it was done. So it's also kind of interacting with Azure. It's also a really nice way to kind of start getting your feet wet with PowerShell if you haven't.
I have a question about the script they used to add the storage,
Sure.
Specify the LUN. Where did you get the actual logical unit numbers from? Did you just know that those were unassigned already?
They're unassigned. So the OS disk is 0, and then you basically start with 1 and work your way up.
So the assumption is the script is that there's nothing wrong.
Correct. Yes. So, and quite honestly, it's whenever you're building these, if you're using PowerShell to do it, it's so straightforward to just delete them and re-add them. I mean, my assumption is if I messed up something, I'm just going to go ahead and delete all the disks and start over, because it really is only like 10 minutes, and I don't actually have to even be paying attention to it while I'm doing it. But you can, tear off single disks and add new ones in if you want, but you have to know what LUN is open, and you can basically just get all the Azure data disks, and you would basically use a format table to basically just get tabular results and throw the LUN number in there, and it'll just show you what LUN's open. This is where I'm going to show my ineptitude with PowerPoint. I don't honestly know how to start from there, so we're just going to zoom along. All right. So those scripts essentially take you up to the point where you've got your data disks. Once you've got all the data disks attached to the VM, you're basically going into the VM at that point. If you want to get really fancy, you can basically whip something up that uses PowerShell remoting that will go in and start grabbing the count of disks in there and start setting it up by, or splitting it off by, what percentages you want your disks to be allocated by. So like for 16, if I have 16 disks, the usual split that I will use is I will use 7 disks for my data drive, 4 disks for my transaction logs, and 4 disks for my tempdb with 1 disk for backups, local backups. You can go in there and you can actually script out, creating the storage pools, creating the disks, and then creating the volumes off of those disks. I did not. It's the GUI, until you start getting upwards of 32 disks, the GUI is actually pretty straightforward and easy to use. So I just go that route whenever I don't have a lot of disks, because one thing is I think it's 8 disks. If you are putting more than 8 disks into a storage pool, there are some settings that you want to start tweaking that are on by default that you don't want on by default. This bit me with 32 disk server, but I am not remembering what that one specific setting is that made me have to start over again. But yeah, if you're getting into a lot of disks, it kind of makes sense to start scripting it out. Okay, so all right, so after you're done basically getting your disks created and presented, you are going to start configuring the OS for deploying the failover clustering feature. So static IPs, disable the Windows firewall for domain networks. That's kind of something that I like to do. I just don't really like relying on Windows firewall for any sort of protection. And then after you've done that, you're going to basically add the failover clustering feature to every node in the AG. All right, and then here is where you're going to create the new cluster. And then this is the setting that I kind of alluded to earlier, where add all eligible storage to the cluster. You want to make sure that's not selected. It is selected by default. So if you're going through the wizard to do this, make sure you kind of take that off. Otherwise, there's a lovely little segue that you'll have to take that I have later. Also note, if you are running cluster validation, storage checks are going to fail. So if you are using a DHCP server in the environment, you want to add a reservation for the cluster vet. And then you also want to change the cluster from DHCP to static because you don't want your cluster IP changing. So this is basically the steps of how you would kind of change that. You basically go into the cluster resource, just right-click it, go to properties, and then you edit the IP address. It'll be at use DHCP. Just change it down to static, and you put the static IP address in that you want to use. Next thing you'll want to do is configure a file share witness for the cluster. So right now you can't really use a disk witness. That is actually something that in Windows Server 2016, I actually wasn't aware of this until the other day. You'll actually be able to specify an Azure, I want to say it's an Azure file table as a disk witness, and you'll be able to use that for quorum on your failover clusters, which is kind of cool because the one limitation of the, or at least I view it as a limitation of, using the file share witnesses is all the file share witness is it's just a text document that has a timestamp that was the last time the cluster configuration was modified. So it doesn't actually store the cluster configuration like it does with a witness disk. If you're using a witness disk, it actually is putting the entire cluster config on that disk, which is kind of nice for kind of redundancy purposes. But yeah, so that's something new that'll be around in Server 2016, not necessarily SQL 2016. And then you are also going to want to modify specific cluster settings for deploying in an IaaS infrastructure. So IaaS is a shared environment. So like I said earlier, you don't have any insight into the performance of the infrastructure or any issues that are occurring in the infrastructure. As such, Microsoft has a couple of good blog posts on best practices around the cluster settings, specifically the delays and the thresholds. So the difference between the delay is how frequently the heartbeat is going out, and the threshold is how many failed heartbeats it takes to generate a failover kind of scenario. By default, I want to say they are 1005, and then the general recommendation is to change those to 2000. Those are in MS, by the way, so it's 1 second. And so you change it, they recommend you change it to 2 seconds, and then you also allow for 15 failures. That puts you right at the health check threshold as well, which is 30 seconds. But it's one thing to be aware of. Otherwise, you're going to run into a kind of a state where you're going to see a lot of occurrences where your availability group basically stops accepting connections, goes into a resolving state because it basically lost connectivity and it doesn't know, and it's going into a revote scenario. So it's trying to figure out who needs to be the primary replica again. It usually winds up staying as the same node, but that was still about 2 or 3 seconds where you weren't able to connect to your database, which is generally not a good thing. So you want to make sure that you don't overlook these, and this screenshot is actually exactly how you would change it. Easiest way is, again, PowerShell. All right, and then so after you are at that point, you want to make sure you add the .NET 3.5. If you're like me, you always forget this, and you're kind of mad at yourself as you're staring at your failed validation tests. But you want to add .NET 3.5 and then install SQL Server. After that is all set and done, go through and make any instance tuning modifications you want to make, and then you enable Always On, which is just a checkbox. After you've got that squared away, you basically create an Always On availability group. I'm not going to go into the details of that. It's the exact same as on-prem. The only portion is the listener that's different. After you create the availability group, however, there are some more cluster settings that you have to go back in and tune, but you can't tune them until after the availability group's created. And these are the least timeouts. It is by default 20 seconds. You want to change that up to a minute. And last but not least, onto the listener. So here are the kind of a little bit more detail on the listeners. So there's the external or public load balanced endpoints. If you need public access to your SQL servers, so you need to come at them from a public facing kind of IP address, and it's not an option to stand up like a VPN to your Azure subscription. This is probably what you're looking at. You want to always apply an ACL to the endpoint. Otherwise, you're going to basically get flooded with all sorts of lovely failed login attempts on your SA password. It's, again, not ideal method of security, but at least it's something. And then you also want to use SSL encryption for your SQL network interface. And then the internal load balance endpoints. So if you don't need public access to your SQL server, and you're able to come at it from private IP addresses inside of your own VNet, then this is definitely the option you want to go with. So internal load balancing, and I kind of alluded to this earlier, no affinity groups. It has to be, the VNet has to be set to the regional scope, not using affinity groups. And the regional scope is something that came out, I think, about 2 years ago. I don't think that's as much of an issue anymore. There was last March into May, Microsoft had a very big effort afoot to basically migrate every customer's VNet to the new regional scope. It was something that happened behind the scenes, and most people didn't even know that it happened. But yeah, so if you have a legacy system that uses affinity groups, your VNet, you're going to want to check into that and make sure that it is at the regional scope. So then, okay, and then, yeah, so access is restricted locally, so you can't get to the SQL servers publicly. And then depending on your need for security, if you still want, it's still not a bad idea to, apply an ACL to the internal endpoints. Security never killed anyone, So, all right. So once you figure that out, and like I said, really ideally, you want to, at all possible times, try and create an internal load balance endpoint. So what you do is you create the internal load balancer, and I will head over to the kind of the PowerShell commands later that show that. That's straight off of Microsoft's website. They give you the commands that you need to run. Like, all that you need to do is set a few variables and just run what they give you. But you basically use their PowerShell scripts to create a load balancer, and then you add the endpoints for the load balancer to your VMs. And then you need to go into the VMs themselves and open up the ports necessary for the load balancer to basically perform health checks, and that's going to be the probe port, which by default on their scripts is 59,999. And then whatever port you want to use for your listener. So if you want to use 1433, then it would be 1433. If you want to use something else for your listener port, then you're going to put that here. Another thing that I would recommend is staging the listener's computer object. And the reason for this is you need to make sure that the clustering computer object, so the cluster computer object has specific permissions to the listener. Otherwise, whenever you try and bring the listener online, it's going to give you an error and it won't actually come online. So for that reason, I recommend that you usually stage the AG listener, the computer object for it, assign the permissions, and then you go back into Windows or Failover Cluster Manager and add a client access point for the listener. After you do that, you're basically going to go in to the IP address resource. You're going to rename it and or copy the name of it if you just want to use the default name that was created. And you're basically going to plug that into yet another PowerShell script that Microsoft was fantastic enough to supply for us. And you're going to basically execute that, and it's going to basically change the IP address for the IP resource to the IP address for the internal load balancer. And I'll kind of point that out whenever we look at the scripts because it kind of makes no sense right now. But it will when you look at it. And then you need to, this is also something I always forget, but you want to make sure you register all of your SPNs for Kerberos authentication. So you want to, and don't forget the listener. So you want to register an SPN for your listener as well. And then the last thing that you need to do is you need to add a dependency on the access point, or it's on the AG for the access point. I don't know why I put that backwards, but I did. So this is basically what that'll look like, is you basically go into the dependencies for the availability group, and there's a drop down for the resource, and you specify the listener, so the client access point, and that is actually what will make you magically see it in Management Studio. So after you do that, the other important thing that you have to note is that doing it this way does not assign the port value to the listener, so you have to go into Management Studio and assign the port, otherwise it's going to be a listener with no port. And then also, if you're going to use read-only secondaries, then you need to configure your read-only routing lists so that way SQL Server knows where it is sending read requests whenever those are specified. And that is essentially it. So one thing of kind of interest, while I say it's a little different, really the only difference whenever you're creating the listener is the stuff with what you're doing with Azure to basically make that IP resource kind of fail over for you. All the stuff that you do in Windows Failover Cluster Manager is essentially what SQL Server does whenever you step through the wizard. It's just you have to do it manually this way. So kind of stinks, but it kind of makes sense too, because there's stuff you have to do outside before you can add it. Here are all the resources that I used in here. I'm going to back out of that though so I can show you guys this part. So this is essentially, this comes straight from Microsoft. They have variables up at the very top that all you do is you fill them out, then you run their script. Right here is where it is actually creating the internal load balancer. As you can see, there's really not much to it. And then right down here, it is iterating through each of the availability group nodes, and it is basically creating those endpoints on those servers for the internal load balancer. And then down beneath it, this is the part where I was saying they are changing. So by default, whenever you create the listener, it's going to basically be configured with DHCP. So right here, this is where they're basically saying, nope, I want to use my internal load balancer IP as my IP address for my listener, and this is basically all it's doing here. And also, as an aside, you can just kind of see right here that 10.0.1.30, and then up here is also 10.0.1.30. So beyond that, that is kind of a high level of Azure architecting, as well as kind of the differences of deploying an availability group in Azure. So with that, that's all I've got. Does anybody have any questions?
Out of curiosity, do you have any comments as far as using platform as a service versus infrastructure as a service? I know this is an open-ended question, but all things being equal?
So I think you're going to find a DBA that's hard-pressed to say that they're not a control freak about their databases and their instances. I don't like that I have essentially no control over the instance. So I don't know if, Joe over in, Ohio is pegging an instance and impacting my performance. In theory, it shouldn't happen, but I mean, theory is theory. As well as, there are other considerations that you have to take into account in terms of maintaining those databases, because I mean, you have to then start looking at how am I going to, maintain my indexes, my stats, stuff like that. And also, and I don't know if they have anything out of the box now for scheduled maintenance, but I mean, I know that there used to be no SQL Server agent, so I wasn't really a fan of that either. But they also have the automation factory now, so I'm sure there are all sorts of cool things that you can do with your PaaS instances. I personally, I feel a lot more comfortable having insight into the OS as well as the full list of DMVs available to me. But there is a use case for PaaS. It's great for places that don't have a full-time DBA. They can't afford one. It's a great way to just have your developers shove their databases up there and they just run, and they generally run well. And there are also some interesting use cases that could get really kind of fun to explore, where if you're sharding your data at the application level, it could get kind of interesting to automate creating new PaaS instances so that you can just dynamically kind of create new shards. But again, my personal preference, I like IaaS, so I like the VMs. Yes.
What's the best practice configuring the VLF and in a replica environment to the Azure?
Okay, I'm sorry, what was that again?
What's the best practice do you have in configuring VLF and the transaction log in the replica environment?
So if you're deploying in IaaS, it's really no different than what you would do on-prem. I mean, any maintenance that you would do to an on-prem instance, you're going to do on your cloud environment. I know that there are I've seen some kind of recommendations around, like, I think the magic number that people say is like 253 VLFs is what you want to keep it under for optimal performance, is kind of your rule of thumb. I think that's in Glenn Berry's DMV kind of package that he releases. I think he has some guidance in there around that. But anything you're going to do from a tuning perspective, when you're doing it on an IaaS instance, so the VM-based instance, you're going to do the exact same stuff there as you would as a non-prem. Anyone else? Yep.
So what do you recommend in between setting up the temp log and the BP on the Azure environment?
Are you, like the tempdb log?
Yeah. Do you have a preference? Can you just go with BPE and
buffer pool extensions. So if you're in a D series, you could absolutely basically use that local SSD storage for buffer pool extensions. It's just sitting there not used if you're not using it for anything else. So if you're throwing your tempdb on there as well as buffer pool extensions, unless it's a problem, you might as well. If you start seeing kind of issues with tempdb performance, you might want to kind of back off on the buffer pool extension. So.
Well, I was having some issue in the performance, but I don't know if it was because, anyway, the issue was they were running some transactions, but they were serialized. So the environment was very slow. I was having a lot of latches.
Okay.
So the issue was more like a deep performance in the Azure. But I don't know, I get rid of the BPE and just use the tempdb, but my
Sure.
question is, there is a better package out there who will actually allow you to use the both, because the BPE goes on SSD and supposed to go faster for me instead of.
Sure.
So it was a question of configuration. So I'm wondering if there's a better configuration out there I should use.
You could just kind of fall back and say, you know what, I'm just going to use some of the spinning disks for my tempdb, and I really want to try and cram as much stuff in memory as possible, and just use the solid state for BPEs. Another option is if you're on enterprise licensing, start looking at maybe finding some nice locations for compression, so that you can cram more data into the memory, like actual memory instead of the buffer pool extensions. I think I saw I think it was the Brent Ozar team, whenever those first came out, they did a kind of a study on how effective they were. I think they were at around like 36% kind of comparison to regular memory. So BPEs on solid state would give you about 36% of the performance you would get on actual memory.
Now, if I remember earlier, you mentioned that you didn't really have any SLAs on that D drive, though, right? So it could be impacted by other activity, so you wouldn't have consistent performance, I guess.
Right. Yes. So
I'm wondering if the BPE is more sensitive to that than tempdb.
Very, very well could be. I honestly, I've not played with BPE. I would much rather just make a larger instance and make it actual memory than I would with the BPEs. I really like putting my tempdb on the local SSD drive. So. Anyone else? No? All right. That's all I got.